Hi, today we're going to talk about the atomic model. People knew that Earth was round long before satellites were invented, about 2,000 years before, using indirect evidence. How? Because Aristotle noticed that the stars rose in a way that indicated that the Earth was round. Ptolemy observed that mountains seems to rise from the ocean when ships sails toward them. And then he interpreted that the mountains were initially hidden by the core of the earth. Much of our scientific knowledge is initially based on indirect evidence. And then as new technology is created, some theories are proven correct and then others are adjusted or redefined. For the vocabulary today, we have atomic mass, the mass of a proton plus the mass of a neutron is in the nucleus of an atom. Atomic number, the number of protons in the nucleus of an atom. Ground stage, it's the lowest energy position of an electron in an atom. And orbital, the area around the nucleus of an atom where the probability of finding an electron is greatest. Photon, fixed amounts of energy in light. Quantum, a fixed amount. Quarks, particles that make up neutrons and protons, classified as colors and flavors, though they don't have to do anything with the colors and flavors that we know. Unbalanced electrons, electrons in the outermost shell of the atom capable of taking part in chemical reactions. Okay, so Rutherford made an experiment. Remember, a model of an atom, and scientists accepted this model, but especially the idea of a nucleus. But they have a question. Why don't the electrons fall into the nucleus? And then came Niels Bohr, and he drew a simple picture of the atom. And he said it consisted of a positively charged nucleus and then surrounded by negative electrons. And they whirled around in the nucleus, like going around and around. And he said that Bohr said that the distance of the orbit from the nucleus depended on the energy level of the electrons in that orbit. So he proposed energy levels of electrons. In time, Bohr's theory of electrons in planetary orbits, because it looks like the solar system, you see, was replaced with electrons being found in energy levels. Bohr's theory was based on the idea of quantization, which states that energy is emitted in fixed amounts called quanta. Okay, now we have the line spectra of elements. One phenomenon that provided strong support for Bohr's theory was the line spectra of elements. So when an element is passed through a prism, like a triangular piece of glass or mirror, it gave off a distinct set of lines within the visible spectrum of light. That means all of the colors that we can see. Because light consists of photons or fixed amounts of energy, Bohr had the idea that these spectral lines of light corresponded to the fixed energy levels of the hydrogen's electron. Um, by looking, by looking at the colors produced in the spectra, Bohr was able to see or tell all of the orbits allowed for hydrogen single electron. And then he calculated this orbiting electron, and then he explained why it was able to resist going down to the nucleus. So Bohr won the Nobel Prize for his work, okay? And he explained how is it that an element creates these colors when you pass it through a prism. Okay, so normally the hydrogen electron, this case is an example, orbits the nucleus in its lower possible position, so really close to the nucleus. That's called the ground stage. And then energy, it's absorbed by the hydrogen in fixed amounts or quants. And then when the electron absorbs energy, it jumps to a higher orbit. It goes up. And this orbit, it's usually unoccupied. And now this electron, it's in an excited state. But soon, that's going to be an unstable atom. And the atom will soon give off that energy as a photon of light. So it emits color, and then the electron goes down again. Okay, and remember that I told you that there are like orbits around the electron, and each of them has a number, 1 through 7. So electrons that are at that same average distance from the nucleus have to be in the same shell. They call it shell 2. Okay, and only in atoms with a very high atomic number do we find that electrons occupy shell 6 or 7. And electrons that are in the outermost shell, the ones out here, number 7 or the last one, depending on the element, those are called valence electron. And this tells us to what extent this atom can combine with another one to have a chemical reaction. Okay, and then for the carbon atom, which we use as an example, it has 6 protons, 6 neutrons, and 6 electrons, and they are divided in levels. In the first shell, you can only have 2. In the last shell, you can only have 4. And here's a chart where you can see how many electrons can a shell contain. Okay, so there are different models about how to show how an atom should look. But this one makes it look flat, and this one makes it look like it doesn't have that many electrons, or that they go slow, when they really go really, really fast, close to the speed of light. Okay, so there's another type of model that it's called the cloud electron model, okay? And it looks like it's a cloud because it shows the possibility of finding electron in different places, okay? Oh, let me correct this, sorry. Okay. Okay. And then about subatomic particles, you have protons and neutrons. Protons have positive charge, neutrons have neutral charge, and they are together in the nucleus, and they're called the atomic mass. Each element has a different amount of protons in its nucleus. And then the number of protons and atoms, it's called in atoms are called atomic number. Electrons are particles that are negatively charged. And then quarks. Okay, so Maury Gell-Mann came up with the idea that within the protons and neutrons are even smaller particles, which he named quarks. And each quark has its own mass and electrical charge, and it's like it has its own qualities, even like if you say its own colors and flavors, though they're not really colors and flavors. Okay, so that would be it for the class of today.